Water liquid-solid phase change. To freeze the water, you need to cool it down. You pull the energy out of the water and the temperature drops. But at the 0 degrees Celsius, you keep on pulling the energy out, but the temperature holds constant. During this process, the water is converted to ice. You need to apply extra work to solidify the water. This work, this energy, is called the latent heat of fusion. In this example, we're going to simulate this conversion process of the water already cooled down to 0 degrees Celsius. To take into account the latent heat of fusion, I'm going to modify the specific heat versus temperature dependency. I will add the step in the dependency, and the area below the step corresponds to the latent heat of fusion value. Okay, let's start QuickField and see how it could be done. In QuickField, I create new problem. Ice. Next. Problem type is transient heat transfer. Model class is plane parallel. Length units are millimeters. Next. Here I should specify the integration time. The final time is half an hour, 1800 seconds, with the time step of 2 seconds. And the initial temperature is 0 degrees Celsius. Finish. On the left is the problem tree, and here I should draw the geometry model. The water film thickness is 10 millimeters. In fact, this problem is one-dimensional, so I can simulate a very small piece of water film. So I insert a rectangle with the height of 10 millimeters and the width of 1 millimeter. Zoom to fit. Here it is. Now let's assign labels. The labels, you can distinguish objects and provide material properties. Switch to Select Objects mode. Click the object to select and type in the label name here. This is water. This is bottom. And this is the cold side. On the left and on the right, the heat flux is 0, and this is the default boundary condition, so there is no need to assign labels. Now let's provide physical properties for these labels. Double-click the label name in the tree. For the water, thermal conductivity is 0.6, density is 1000, and specific heat is 4200. And I'm going to include the latent heat of fusion into the specific heat capacity. So instead of the static value, I'm going to specify the dependency. Here I have the data in the file. Just select, copy, and paste it here. Now, if you take a look, this is the heat capacity of the ice. This is the heat capacity of the water, and inside here we have the step which takes into account the latent heat of fusion, 334,000 joules per kilogram Kelvin. Okay. Now for the boundary. At the bottom the heat flux is 0, and at the top we have the cold side with a temperature of -5 degrees Celsius. Geometry model and the data are ready. Before I start the analysis, I should build the fine increment mesh. Just press this button and the mesh will be generated. Save all problem files and solve the problem. Let's take a look at the results. Here you can see the temperature distribution in the water after half an hour of freezing. You see it's -5 here, so it is ice here. Let's adjust the range, minus 0.1 and 0 here. So it is ice everywhere. We do not see any place with red. But if you change time, you will see here is the water and here is the ice. And this is the fusion dynamic. Apart from the color picture, you can click any point and take a look at the time plot, how the temperature changed in time. And the exact values you can see in the timetable. Time and the temperature in this specific point. You can also use the contour tool. Click to select this edge and take a look at the temperature distribution on the XY plot. Again, at this specific moment of time. Initially, it was 0 degrees everywhere, but then it started to cool down. So using this modified specific heat versus temperature dependency, you can simulate melting and fusion processes. If you search for the water, liquid, solid phase change on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the result pictures and download the simulation files. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition, that you can download from our website for free.